Hello folks and welcome to this final video in the series of structure-based testing where we're going to be having a look at decision testing. So a decision, first of all, we can define that in terms of code as anything like an if statement, a case statement, any sort of loops, whether that be while, for, etc. And each of these different structures, as we said, contains a decision, a binary value, true or false, is going to determine what happens in the code. So a more comprehensive way of evaluating our code is to actually look for something called decision coverage rather than statement coverage, and we'll explain that a little bit more throughout this video. The first thing we need to note though is that there's a slightly different equation we use to see if we've achieved 100% decision coverage, and again 100% coverage is our target. So in this case, we're looking at the total number of decisions we've exercised, or should I say decision outcomes that we've exercised, divided by the total number of decision outcomes multiplied by 100 to get us our percentage. Now, before we get into all of that, there is a relationship between statement coverage and decision coverage. So one thing to remember, and again, this is useful by way of our class test coming up, 100% decision coverage guarantees that we have 100% statement coverage, but not the other way around. And that will make more sense as we get through the next couple of examples. So if we remember our example here where we read in two values, had one if statement, and then we had one test case which perfectly allowed us to get 100% statement coverage. That example will actually give us 50% decision coverage. So let's have a look through here. We're reading in the values A and B. In this one test case, the value of A is greater than B, which takes us over to C, but then we come into the end if. At no point do we actually test this branch, and that's a problem because, especially we think back to things like boundary value analysis, we know that we can have a lot of errors in and around the decision points in our conditional statements. So decision coverage is a nicer target, a nicer type of coverage testing to use in a lot of situations. So if we just have a look at the formula here, we can see decision coverage. There's the formula. We've only tested one decision outcome, which is the true over the two possible being our true and our false, multiplying by 100, and that only gives us 50%. So our target hasn't been met. So what do we need to do? Well, we need to add a second test case. We have the original test case where A has the value of 10 and A has the value of 12 and B has the value of 10. But we introduce this new one where A is a value of 1 and B is a value of 100, which allows us to test the false path as well. If we have a look at our updated decision coverage formula, we can see we've now achieved 100%, which is our target. So in this case, the minimum number of test cases that we can use to achieve 100% decision coverage is 2. Now, in that, you've got the obvious disadvantage of decision coverage. Generally speaking, it will require more tests to achieve 100% decision coverage than a corresponding statement coverage example. And we all know how long it takes to write those test cases. So ordinarily, a little bit of risk analysis will help you decide this if you're doing it manually. If you have automated tools, which is the more common way of doing this, usually there's no extra work effort on the part of the developer or tester beyond programming in the initial test value, so it's not as big a consideration. But generally speaking, decision coverage, we're going to have more test cases. Okay, so let's have a look at this exercise. So again, I'm going to pause for a moment and let you guys work through and plot out the flowchart for this. And what I want you to do this time is work out the minimum number of test cases you would need in order to achieve 100% decision coverage. And furthermore, for each of those test cases, you should set out the values of the various inputs for each test case. Okay, looking ahead then, you should have hopefully got a flowchart resembling this with a number of different flows. One thing I should say is in the case of our pseudocode here where we've just got FU, this is assessing a Boolean. So hopefully you've covered this inside your Java class with Aiden, but when we see an if statement represented like this, we know that you can only have the values true or false. So this means FU is true, or if we see an exclamation mark in front of it, that would mean FU was false. So looking how we translate here, FU is true, then we have the true line, FU is false, we have the false line, so on and so forth. So now that we have our structure in place, we need to figure out what test cases we actually need to achieve 100% decision coverage. In this case, I've gone on ahead and drawn the lines in, and your answer should be 4. And what you're looking for here is that you should have, in this case, 4 examples where a line is only running through at once. So let's take test case 1 here. So we're starting at this point. We're following the true line, but then we're saying S is equal to false. And we can see on this particular statement, only the red line is running through it. Excellent. And then we go through our end ifs. We look at the second one, test case 2, we start off with true again, but then we're going false. But we'll notice that this particular instruction only has one line going through it. A similar pattern then we can see here with test cases 3 and 4, where these 2 instances of I only have one line flowing through them each. That's a good indication that we've got the minimum number of test cases we need. If we find that every single instruction in my diagram had at least 2 lines flowing through it, that's a red flag that we're not actually running the minimum number of test cases, and you can probably rejig things a little bit to improve your testing efficiency. Final little diagram here, we're just highlighting all of our possible decision points. So you can see we've got 6 there in total. Looking at our decision coverage formula, 6 over 6 is 1 multiplied by 100 gives us our 100% decision coverage, and therefore our target is achieved. So as a technique, it's very similar to statement-based testing. Just what we need to remember is that decision coverage is a little bit more comprehensive. It ensures that all branches of our code are executed. It's going to be really good for finding any errors in and around the decision points of our if statements or loops as well. But it does tend to generate a bit more in the way of test cases. Looking ahead to the class test, just remember you should be able to look at some pseudocode, be able to draw a flowchart from that, and work out from there the minimum number of test cases you will need in order to get 100% statement coverage or 100% decision coverage. Likewise, we should be able to give you some pseudocode and give you some pre-configured test cases, and you should be able to evaluate those and tell me, based on that, what would the statement coverage and what would the decision coverage be. As always, folks, any questions, do please get in touch. That is the end of our structure-based testing videos, so we'll be moving on to topic 5 in the next set of videos. Thank you very much.